In today's session, let's understand two important concepts: merge and rank. Okay, let's observe carefully here. Straightforward concepts. Let's do it carefully. Here we go. Let's take an example straight. Understand the required concept. Assume, for example, you have a database and there are two tables, okay? Orders table with ID, title, measure. Inventory table, ID, title, measure. Two different tables. And there is some sample data available in both tables. Select. Now here is the concept. There are two different tables, say two identical tables. Our requirement is to compare above two tables. Generally, for comparison, we use joins. But here the requirement is bit different. To compare two tables, identify. So here it is, identify. So here we go. Identify, for example, matching data based on ID column. Okay, 3, 3. One row is matching. If ID is matching, measures should be added. 100 plus 200 should be given 300. Identify matching data based on ID column and sum up the measure column values. Same way, identify missing data based on ID column. 1, 2 are missing in second table. Insert such missing rows into second table. Compare two tables. 1, 2 should be inserted to second table. For 3, matching value measure should be added. Means we need to perform something called UPSERT. Remember, a new technical term for us, UPSERT. What does it mean? Update plus insert. We are modifying the measure value. Identify matching data based on ID column. Sum up the measure column values and update the second table. Okay, that is update. Here insert missing rows to second table, that is insert. Okay, so update plus insert, single transaction, single operation, UPSERT we call. Yes, to perform this operation we need to use merge statement. This is a concept. Syntax for merge, or simply say merge statement syntax. Merge target table for updates, comma inserts. Merge target using source table for comparisons on column, or simply say comparison condition, like first table dot id equal to second table dot id. Comparison condition. When matched, then what you would like to do, say required DML operation. Same way, when not matched, what you would like to do, say required DML operation like this. So when matched, when not matched. At the end, we need to have semicolon, remember. At the end, we need to have semicolon. Match, not matched. At the end, we need to have semicolon activities this way. Observe carefully. Okay, let's see. Let's take an example here. A simple, straightforward concept. All we do is select from orders table and inventory table. 4 rows in second table, 3 rows in first table. Now what's our requirement? Compare these two tables. Merge. What to merge? Target. What's the target? We have to update or insert to inventory using orders table on condition orders.id column equal to inventory.id column. Observe carefully. Then when matched, 3 more lines. When matched, then what we do to do? Update set inventory dot measure. This one, this measure column is there, right? It's a column, measure column is equal to, we need to have orders dot measure plus inventory dot measure, a equal to a plus b, something like that. So 100 plus 200, 300 value should be in this way. Not matched, what you would like to do? Then insert values. Generally we say update table name, insert into table name. Here table name not required because you already mentioned the target table for upsets and inserts. You mentioned the target table first. Any update or insert, it goes to the target table automatically. Okay, with this information, values, what values? Orders.id we have to insert. Next column, title tag, the column name. So we are comparing two different tables. Number of columns should be same. In this case, column names may be different. Those columns we have to mention here. So inventory is accepting 3 column values. So ID, title, measure from orders table. Observe carefully here. Initially, inventory table has 4 rows. Whenever you say merge, remember merge target using source, using the source for comparison on condition. When matched, perform one operation. When not matched, you perform other operation. Now select from inventory like this. You get ID, title, measure. Observe carefully. Okay, ID, title and measure in this way. Next, with this information, yes, we are understanding here 2 rows insert. Okay, sir, this one 1 2 missing data, insert 1 to insert, third row got update. This is what UPSERT means. So total 6 rows. If you are going for Azure Data Engineering, ETL, or even BI, any kind of business intelligence like MSBI, we say historical data, data warehousing. In data warehousing technologies, this UPSERT is very much used. Compare OLTP and data warehouse. Identify missing data, insert matching data, look for updates. We say incremental load concepts. So the practical real-time use of merge is in data warehousing technologies like Azure Data Engineering, a drag and drop concept for easy data warehouse design, even in Snowflake. So remember, merge is a statement to compare two tables, identify matching data, perform one DML like update, then missing data, perform other DML like insert. Once you practice this item, then you'll practice other important concept called window functions, also called as rank functions, an interesting and easy reporting item. Merge is mainly for data warehouse, BI, MSBI, Azure Data Engineer, Snowflake, etc. Whereas, so I'll just write it here, real-time use of merge statement, incremental loads in data warehouse, DWS design. Remember, in our introduction class, we understood types of databases, OLTP, data warehouse, OLAP, etc. For data warehouse design in Azure Data Engineering, we call it ADE, and Snowflake, Cloud Technologies, or MSBI, Microsoft Business Intelligence, and on-premise, non-cloud technology. In these cases, we make use of merge for incremental loads, compare two tables, identify matching data, identify missing data, do DML activities. Other important one, window functions, also called as rank functions. Window functions, also called rank functions. For example, here it is, requirement. Say requirement, how to generate sequence of values. Generally, we use identity property to generate sequence of values. Identity of seed, comma, increment, 1, 2, 3, 4, so on. Here, for existing tables, if the table already exists, identity is for brand new table. If table already exists, you want to generate a sequence of values exclusively for reporting requirements. Mainly for reporting requirements, you would like to use this one. What we'll do here, let's see. We have something called as row number. What row number gives you? Let's see. Star means all columns from the inventory table plus row number is a function to generate sequence of rows. Syntax: row number over order by measure. Sequence number over order by measure. This gives you sequence values 1, 2, 3, 4, so on. Remember, from reporting perspective, we need to understand these window functions. Same way, something called rank. It also has over this one. Rank you would like to compute based on, here over means based on ordered, sorted measure value. So if measure is same, you'll see one sequence. If measure changes, sequence changes. That is rank. If measure changes, sequence changes. Same measure, same sequence. See this column. Measure changes, sequence changes. Now, same way you have something called DenseRank. Here also, measure is same, sequence is same. If measure changes, sequence changes. That is DenseRank. This one. Here we go. Next. Here, what's the difference between them? Rank. Here it is. Rank. If measure changes, sequence jumps. What is 3? 3 is the row number 3. 1, 2, 3. Same way measure changes again, sequence jumps. So by seeing the new sequence number, we know the row number automatically. If it is dense rank, there is no jump in sequences. Guaranteed sequence increments to the next number. 1, 1, 2, 2, 2, 3, 3, 3, 3, 4, 4, etc. If measure is same, sequence is same. Measure changes, sequence increments. That is dense rank. Dense always gives you ordered sequence. But sometimes, for example, assume a bank statement, a report of all transactions. Sometimes we'll see credits, credit 1, credit 2, credit 3. Again debit 1, debit 2, debit 3, like this. Reset in sequence, we use something called partition by. So partition by gives you reset in sequence. See there, first measure, one sequence. Second measure, reset in sequence. Third measure, again reset in sequence. Reset means starting again from first sequence value. So 4 different rank styles. Let's put them together. Here it is, combining all above rank styles. Rank functions, also called rank styles. What we'll do is simply have this select statement. See here, select statement as sequence 1 comma. So here we go, rank sequence 2, like this, comma, dense rank sequence 3, comma, row number gives you sequence 4 from table name. Now here you will see the data side by side. First sequence, row number, just repeating it, row number, unique sequence, rank, same measure, same sequence, new measure, new sequence, jump in sequence based on the row number. Again new sequence based on the row number. Dense rank means same measure, same sequence, new measure, next sequence number. Row number over partition by measure means same measure, one set of sequence, new measure, reset in sequence, credit 1, credit 2, debit 1, debit 2, debit 3 in a banking environment. So from analytics perspective, if you are into Power BI or Azure BI technologies, you have user interface for these activities. But to understand that user interface, good to know the syntaxes. If you are going for traditional reporting like SSRS, MSBI SSRS reporting services, no user interface for the rank functions, we need to write this kind of query to generate the sequence. For for Power BI Azure cloud-based reporting, no problem. Nice user interface waiting for us. We should be aware of this technical terminology. Now the practical use of rank functions reporting. Another very important use, here it is. Other use of rank functions to identify duplicate rows in a table and delete only the duplicated rows. You don't want all rows to be deleted. You just want to identify duplicate rows and delete only such duplicated rows. How simple. Measure is duplicated, sequence increases. 200, 200, sequence above 1 means duplicate. Let's understand carefully the practical use of rank functions for data validations, data cleansing, we call it. Data validations and data cleansing activities required for everyone, right from development to ETL, everywhere. For this purpose, right now I have 6 rows. I will try to insert 2 more rows, okay, this way. 7 and 8 are duplicated, okay, entire row getting duplicated. So here you will see 7, 8, those rows are duplicated here. Our requirement, how to identify the duplicates, requirement, how to identify duplicate rows in a table. From the previous query, we know partition by measure. Measure is duplicated. Same way, what's our requirement? Not just measure duplicate. I would like to have duplicate row, complete row. So what I'll do is ID comma title tag comma, title tag is the column name. Okay, so here we go. I'll just put this way. This is the actual query. Now order by ID comma title tag comma measure, and same way partition by ID comma title tag comma measure. This gives you sequence 2 greater than 1 means duplicate row. Observe carefully. Here rows with sequence above 1 means duplicated row. This is the concept. Now what's our requirement? Identify duplicate rows. Now requirement, how to remove duplicated rows. 2 things, identify and delete or remove duplicated rows. We know how to identify duplicated rows with over partition by ID title measure, order by ID title measure. Now how to remove them? Simple. All we do is here, all we do is create, observe carefully here, create view for data, the actual data. I'll say view for removing duplicates, view for removing duplicates, create view name as, okay, select. You create a view like this. Firstly you store the query inside a view like this, sorry, this one. Now what I'll do is select star from view name. You get the output as it is. What I'll do here, where sequence column is there, right? Sequence 4 greater than 1. This gives you duplicated entries. What's our requirement? not to identify the duplicates, but to remove the duplicates, right? Our requirement to remove the duplicates. Okay, so what we'll do here, let's see. Delete from view name where sequence above 1. What happens? Remember, view does not store any data. View does not store any data. So any modifications on the view actually impacts base table. What does it mean? Select from table name, you will see correct data, no duplicates. Whenever you delete from a view, base table data gets removed. Which data? Where sequence above 1, the duplicated rows will be removed. That is the actual concept here. So practically in real world, we go for this window functions mainly for two different purposes. Number one, reporting. Number two, for data validation, like cleansing the data, remove duplicates, identify duplicate rows, and then remove those duplicate rows. Remember that. So here we learned two important things. One is merge and other one rank function. One is merge and other one rank functions. You'll practice these items carefully. Use me for your doubts as usual. Okay, just make sure you complete your practice step by step, understand it slowly, then it should be easier, straightforward to continue for our actual journey for ETL or MSBI or analytics or development. Journey should be easier with all these concepts. We'll stop now. You'll practice all these items carefully. Use me for your doubts as usual.